Alright, in this video, let's continue our work on the song editor mode. More specifically, we're going to put together the first input mode. This is going to be note edit mode. Now we're going to need to do a few things like some obvious input handling. We'll need to make sure that we are able to toggle notes into and out of existence, and we're also going to need to be able to move the edit cursor. So we're going to try to build up in kind of a foundational sense. We're going to begin with some very simple inputs to allow us to move the cursor, but then we'll need to address problems like we'll need to see the cursor, and then we'll need to be able to move from tracks, and we'll simply progress as need be to get note edit mode fully functional.
Okay, so where are we going to start?
Down here, we'll scroll down to input pressed, and we will begin with some input handling. So here we have the end of our else if statement for all modes. So we can jump a few lines past that, and let's drop down a note saying that this is going to be input specific to note edit mode. Now, in order to make sure that it is indeed specific, we'll do a check, and before we run any of these input checks, we'll make sure that we're in note edit mode. So that will be if current mode is equal to edit mode dot note edit, and this is how we will apply everything only to edit mode. Now, of the various things we're going to need to handle, one of those things will be handling the left and right inputs to let us move our cursor forwards and backwards. So let's drop that part of the if statement in first. So in note edit, if we have a named input, that is equal to named inputs dot right, then we're going to need to advance the cursor forward. Now earlier we had laid in the skeleton for a method called move cursor forward. So we're going to do just that. So the left and right inputs are going to be one of the most simplistic elements of note edit. So with this if statement, let us also copy the whole if statement, paste it to duplicate it, though we will change the if statement to an else if, and we will change the input being looked at to inputs dot left.
Okay.
So detecting the left button will allow us to move the cursor back, so we'll change this call to move cursor back. Now, of course, at this point, these methods are still just skeletons, so we're going to need to turn our attention to these utility methods and begin putting some code together. So if we scroll back up to our utility methods section, we have move cursor forward and back. Alright, move cursor forward is going to need to take the edit cursor field, and it's going to move that forward. Now when it moves it, it's going to need to move it based on the snapping setting currently held in edit granularity. So what that means is we'll need to do two actual operations: move the note and then make sure it snaps to the proper place. So we'll do this beginning with our edit cursor. We'll say that edit cursor is going to be incremented, so we'll be moving it forward, and the amount that will move this will be a note given by edit granularity. Now, in order to represent that note in terms of ticks, we'll have to first resolve a whole note value, a whole note's worth of ticks, then we can divide by edit granularity, and that will give us our final note.
Okay.
So to get a whole note, we'll begin with the note value we do have, which is held in song.quarter note.
And multiply that by 4.
And again, 4 quarter notes would give us a whole note. So once we have a whole note's worth of ticks, we can then divide by edit granularity, and that will give us an amount of ticks specific to the note setting in edit granularity. Alright, now that we've moved the edit cursor, we want to make sure that the edit cursor lands at a grid space currently defined by edit granularity. So we'll take edit granularity, or excuse me, edit cursor, and we'll make sure that we set that to a snapped value. We'll get that snapped value by using our current song and issuing a snap note call. And into snap note, we will feed the current tick that we reside at, which is edit cursor, and then the note to which we would like that value snapped, which is edit granularity. So that'll take care of a case where, let's say because of some form of playback, we managed to, somehow land off of the grid. That means the moment we move the cursor, it will both move and get snapped back onto the grid. Now we can do very much the same thing inside of move cursor back. So much the same, in fact, that I'm going to copy both of these lines and paste them inside of move cursor back, and all we're going to change is the offset. So instead of incrementing edit cursor, we will decrement edit cursor. So we'll move it back by the same note calculation and then run the same note snapping. Now, one difference that we're going to have when moving the cursor back is we're going to prevent the edit cursor from going negative. Since in this case the song is always supposed to start at tick 0, we don't want a user to go and be able to place negative ticks, because that would interfere with our beat leading calculation. So that means the moment we move this cursor, we'll do a check and see if it has gone negative, we'll simply place it back at 0. So if edit cursor has for some reason been set to a negative value, and therefore is less than 0, then we will set edit cursor to 0. Alright, that takes care of moving the cursor around. So at this point in time, if we were to, looking at our input code, hit our right and left buttons, we should be calling these methods, and moving that edit cursor. Now, at the moment, we wouldn't be able to see that. We're not currently drawing the edit cursor. So before we test this functionality, let's turn our attention to the horizontal renderer. So looking over here inside of our Solution Explorer, let's go down to Game and grab Renderer Horizontal. Inside of Render Horizontal, let's scroll all the way down to the very end of Draw. You can see the last two things being done are the note drawing and the track titles. So what we'll do is we'll jump in right between notes and track titles, and we'll drop down a little bit of code for drawing our edit cursor. Matter of fact, we can denote that here as a section and a comment as edit cursor. Then we'll put together some code to draw the edit cursor. Now, we want to make sure that we don't draw an edit cursor in any other game mode, because a ghost note appearing in other songs would be inappropriate.
Yeah.
So we'll
confusing to say the least.
We'll first check global state and see if edit mode is currently active. The same flag that's currently being used to tell the song selection screen to go into edit mode. So if we are currently in edit mode, then we need to draw our edit cursor. We'll do that by getting a position, making sure that we pan it appropriately using scaled cursor, and then finally draw it. In order to gain access to the position, we'll make a local vector2 called note position, and we'll set that, or rather we'll gather that, by using the getStaffPosition method. And then into getStaffPosition, we need to feed in the edit cursor's tick value and the current track that the edit cursor is on. So to drop some of these in, we need to look at screen edit, because that's where those fields are defined. Edit cursor is going to be the tick value. Screen edit.edit track is going to be the track value. And of course we need to pass in the song which this will be applied against, and that is going to be the current song passed into this render or draw call. So that will gather a current position based on the edit cursor's own position. Now we do need to make sure that that position is visually panned appropriately as the song progresses. And that'll be done using much the same method as we did here inside of the note drawing itself. Once we gain that position, we simply subtract scaled cursor from it, and that will apply the panning. So, note position, we will take note position.x minus equals our scaled cursor value here inside of the renderer, and that will take care of visual pan. Alright, that will leave note position in a state ready to go to be drawn to the screen. So we will make our call to spritebatch.draw, and we will draw out the edit cursor. The way we're going to draw the edit cursor is it's basically going to be a ghost note. It's going to be drawn using the note texture, but we're going to be drawing it using the specific color for edit cursor. As a matter of fact, just as a refresher, by what I mean by ghost note, if we wanted to, we could jump back into Style and bring up our Style XML file. And remembering that edit cursor is set to this transparent value, what we're going to get is an actual transparent white note that's placed over the screen. The reason we leave it as transparent is to make it so that if the edit cursor is currently over another note, we can see through it a little bit and still see that there's a note below the cursor.
Very cool.
Alright, so to draw this, since we know we're drawing a note, we'll draw using the note texture. Let's actually move over to the 6th overload of spritebatch.draw so we can see all the fields we need. Next up is position, where we will drop in our note position variable. We'll have no source rectangle, so we'll leave this as null. For a color, we'll grab style colors dot edit cursor. For a rotation, we'll give a value of 0f in rotation. Vector 2 will be given by note origin. Scale will be a value of 1. Sprite effects will be set to none, and layer depth will be set to 0. Alright, with that, we should have all of the drawing in place, and if all of our code back in the edit mode for moving our cursor forward and back is working, we should be able to test at this point. So we'll load up the game, go into Song Editor, load up a song. We can see at the top there we have a faint note being drawn. If we move left and right, we can see that we can move that note.
Very nice.
Now at the moment we can't move up and down because we haven't addressed the up and down keys yet. But you will note we are locking to cursor 0, so we cannot move past the beginning of the song. And we'll note another problem we'll need to address is if we move the cursor off screen, it simply disappears.
Gotcha.
So we'll be addressing that momentarily. But before we get into that, let's now handle up and down. So let's add some more else if statements in. So we'll say if named input is equal to named inputs.up, then we need to address the edit track. So if moving up, we'll take edit track, and we will set it to be equal to our edit track -1. Again, moving up would be moving towards track 0. So basically, mathematically, this is just edit track -1. We're not going to leave it this simple because that would allow us to move the edit track negative, and that would cause problems when we go to place the note.
Would the cursor just disappear, or could you break something?
It depends on how many things we're resolving.
Gotcha.
If we're just placing the note, we'll end up going negative. If we're trying to address a track name or track color at any point, any of those track-based lists, then we'll end up with an out-of-bounds reference. I mean, it wouldn't hurt anything to test. We could, just for the sake of experimentation, if we moved up, oh, there we go.
We're
so
flying away.
It was the former. We're not actually addressing those lists, but we are moving the edit cursor up off the top of the screen. If we move up again, then we disappear entirely.
Nice.
So, while it's interesting, it is indeed inconvenient. So let's make sure we lock the edit track to track 0, meaning we cannot move past track 0 by going up. We'll do that with a call to math.max, telling it that we would like to have a value of whichever is more, the value 0 or the new edit track value. So what this means is if we happen to go negative, 0 at that point would be greater than the negative value, and 0 would get chosen. So we can test that here inside the song editor. Hitting the up arrow key now will not move us off the track.
Very cool.
Though we now need to be able to use the down arrow key. So for the sake of time, let's grab our code that handles our up input, duplicate it so that we can handle the down input. And when we're moving down, what we need to do is take our edit track and advance it. And let's see, we'll pull our locking out just to show that if we can go off the screen negative, we should be able to go off the screen positive. So loading up a song, you can see that we can move the track down, and we can conveniently move right off the end of the staff.
Nice.
So some more locking is in order. So we'll do this with math, this time with math.min. So we're going to specify whichever value is less, and that's going to be either a valid track less than the last one, or the last track itself.
Now, you don't just want to actually plug a number in here, because it's possible somebody could be adjusting their game to have more than, what do we have, like 7 tracks or 8 tracks?
7 or 8 tracks, yes.
Maybe they have like a setup with 15 tracks.
Well, in that case, in order to make it adaptable, like you're describing, we'll look at the current number of tracks by looking at the track names list. So that would be inside of config. We have track names. Track names has a count, and we'll use that to describe how many tracks we have. Now we'll subtract this by 1, since we want to make sure that we stay within our 0-based range. So that means whichever value is less, the number of tracks we have, or the edit track plus 1. So to test, that means we can now move our cursor down, and we lock to the bottom of the screen.
Very nice.
So lock to the top of the staff and the bottom. We can move left and right. We're locked as far as not going negative in 0 for our tick.
Mm-hmm.
But we still have this one nagging problem of our cursor going off screen to the right.
Yeah.
We don't want to be able to move the cursor off screen. And rather than physically locking the cursor on screen, because if you're thinking about it, let's say you were wanting to place eighth notes, like maybe you're doing eighth note hi-hat notes.
Mm-hmm.
If you moved off the edge of the screen, you don't want to lock the cursor. It would still be nice to be able to move that final eighth note and add another note in place.
Right. You just want to maybe take the screen with you?
Exactly. So we'll take it where if the user moves the cursor off screen, we'll just update the screen to move the appropriate amount and put the cursor back on screen. So that's where we need to add a little bit more code to our move cursor forward, move cursor back. What we're actually going to do is we'll leverage some of the functionality inside of the current renderer, since again the renderer can be given tick values and be asked where those exist.
Mm-hmm.
That position can be checked to see if that position would be on screen or not. And if the position happens to be off screen, then we know that we need to move the song a little bit to get that position back on screen.
Gotcha.
So the code that we'll use to find the position is going to be from the renderer. So looking at the check itself, you could say, imagine this code is going into something like an if statement. You've got the value renderer. Renderer has the active renderer. The active renderer, being a renderer, will give us access to the getStaffPosition method. So like we had called over and over inside of the renderer, we did make that public so we can access it outside the renderer. So for getStaffPosition, we can ask it where the pixel location of the current edit cursor is. And generally that would just be dropping in edit cursor. Now we do need to take into account the fact that the song may have moved or may have panned on screen, and it's going to have panned based on the song's own cursor. So we'll actually subtract song.cursor, and that will give us a value of where physically on screen we should be looking. Now the method requires a track to be passed in. We're not worried about track information, so we'll specify that as 0. For the song, we'll pass in the current instance of song here inside of edit mode as this.song. Now once we run that call, of course, it returns a vector2. We're only interested in the x component, so we'll say the result of this method .x. Now if that value happens to be greater than the width of our screen, then we know that we've gone off screen. So that would be if that value is greater than global state dot fixed drawing width. So if we've gone off screen, then this case would return a value indicating whether or not we're still on screen. Now, as I was saying before, you could imagine this entire statement being placed inside of an if statement. But just to make sure that the cursor does indeed get placed back on screen, we're going to run it in a while statement rather than an if statement. The idea is that if an individual move doesn't put the cursor back on screen, we allow it to continue until the cursor does get placed on screen. So we're going to drop in a while statement. So we'll say while render get position of the current edit cursor, including the pan value. As long as that is greater than the fixed drawing width, we know that the edit cursor is off screen. And if that's the case, we'll take the whole song and we'll make the song seek forward. And we just happen to have another utility method called seek forward. Granted, it hasn't been coded in yet, but we'll address that shortly. Now, looking at this scenario, we would end up in a similar scenario for going back. Once we had moved forward in a song, if we move the cursor off the left, we'll need to move the entire song to bring it back on screen. So we'll do much the same thing here inside of move cursor back. As a matter of fact, we'll start by copying the entire while statement, pasting it into move cursor back, and we'll change a few of the things that end up happening. First is, instead of looking at the fixed drawing width, we'll say if the resulting pixel location of our edit cursor is less than 0, then we're off the left side of the screen. And instead of seeking forward, we need to seek back.
Gotcha.
So that takes care of the detection for going off screen. It's at this point that we need to implement seek forward and seek back to be able to apply these. So let's begin here inside of seek forward. all we're going to do inside of these seeking methods is move the song by an entire measure. Just to make it simple for lining things up on screen, we're going to move by entire measures, and that way you get kind of it's almost like a snapped feeling to the movement.
Almost like a page up, page down style of effect, but just working on a single measure at a time.
Yeah, that's a good way of describing it. It's very much like page up, page down, 4 measures. So, in order to do this, we'll grab our song, and we'll issue a set cursor call, because of course it's the internal song cursor that ends up describing our visual pan. So what we're going to do is we're going to advance by 1 measure's worth of ticks. That means we'll need to start at the current song's cursor, song.cursor. So we'll take song cursor plus song.ticks per measure. So that would advance us 1 measure forward in time in terms of ticks. Now we do want to make sure that snapping is applied so that if something moved in an incorrect amount of ticks, we do snap back to a direct measure value. So we'll take song, we'll run a second call to song.setCursor. This time we're going to issue a song.snapTick. So what we'll do is say song snapTick. We need to pass in the current cursor, so we'll pass in song.cursor. And then the snapping value, which again is going to be the number of ticks in a measure. So song.ticks per measure. So that'll finish up the call to snap tick. 1 more parenthesis will finish up the call to set cursor. And now, if you wanted to, all that could have been done as a single assignment. We could have taken this operation of cursor offsetting by ticks per measure, placing that here. It was broken up into 2 statements just to better use the screen space available. All right, that takes care of seeking forward. Now we need to address seeking back. And it's going to be a very similar function. So we'll copy both of our operations, and we'll change the offset to be negative. So we'll start at our current cursor and move backwards 1 measure's worth of ticks, apply the standard snapping, but we'll do one thing in addition. We'll make sure that we don't move the cursor negative, because again, we want to make sure that 0 is always our starting point. So we'll say if song.cursor is less than 0, then we'll set the song's cursor, so song.setCursor, to a value of 0.
So this keeps us from being able to move the measures back to before the song begins?
Exactly. Which, I mean, depending on how you wanted to work with it, it could, in a certain sense, be helpful to let you move a lead-in worth of measures backwards. Like, let's say you moved a measure back negative, then that would give you a lead-in. But that's more a matter of personal preference. Here, since we were saying that everything starts at 0, the song itself starts at 0, we make sure that we always seek back to 0 if we're going back to the beginning. All right. Now, while we're addressing all these utility methods, since we've gotten through both moving, seeking, and all we have left is edit cursor, let's drop this one in place as well.
Okay.
Since this one is very simple. All we're doing is place edit cursor, is taking the song's own position, where it has panned to, and we're going to snap the edit cursor to that position. And the key there is using snapping, because of course the song cursor itself moves tick by tick, and we want to make sure that our edit cursor stays snapped. So what we'll do is we'll take edit cursor. We're wanting to gain access to song.cursor, but obviously we need snapping here. And so rather than just directly copying this value, we'll instead issue a song.snapTick. Actually, in this case, let's use snap note, because then we could make better use of our edit granularity. So we'll do snap note, pass in song.cursor as the tick value, and edit granularity as the note to which we would wish to snap. There, now that'll take care of things like when we reach the end of a song, the song ends and calls place edit cursor. Now edit cursor will appear on screen as soon as we stop playing. Alright, so all of that to make sure that we can move the cursor off screen and have the song update. So let's build and test. So back into song editor, we'll load up one of our songs, and now if we begin moving the cursor, so one more will move off screen, and now we see all of the notes move.
Nice.
So if we keep moving the cursor, we move.
Yeah, we're not going to see much motion here.
But we can kind of see that there's that last kick note. We move some more, now we're another measure past, and now off altogether.
Very nice.
So we can do the same moving back and testing all the way back to the beginning. Actually, I guess you don't need to test the beginning because we know that we're going to hit there. You will note the fact that we can't actually set the screen's cursor all the way back to 0, since we can't move past the beginning of the song in order to reach and cause the snapping to occur. But we'll take care of that when we address things like the dedicated song seeking mode.
Okay.
So what we do have at this point is we have full control over the position of our edit cursor. Now we need to take a look at placing notes. So that will take us back to our input section, input pressed, down into the note edit mode section, and we need to add an additional else if clause. This time we'll look for the note input. So if named input is equal to named inputs.note, then we're ready to either place or remove a note. So, moving back over here, we now need to check the current location, because now we have an edit cursor location given by edit cursor and edit track. Now, since we need to toggle notes, that means before we place a note, we need to check the current position and see if a note exists at that position. And if it does, we need to remove it. Otherwise, we're free to add a new note. So, what we'll do is we need to get access to a specific note by a tick value, and we'll do that using the song's getNote method. Once we get that note, we'll record it here into a local variable. So I'll make a variable called note. We'll set that to be equal to song.getNote, and we need to get a note at a specific tick and track, so we'll plug in edit cursor for our tick and edit track for our track. So get the note currently at the edit cursor. Now, if that note is equal to null, that means that getNote was unable to find a note at this value, which also means that if you want to describe this position as a grid slot for our edit grid,
means there's nothing in that grid slot.
Exactly, it's empty. So that means we're free to add a note. Now, if the note was not null, we could handle that using an else statement. Then we need to remove a note that was found. So let's begin with adding notes. If note was null and the slot was empty, then we need to add a note to the song's notes list. So song.notes.add. And we'll add in a new note item. And for that note, we'll specify edit cursor for the notes tick and edit track for the notes track. And then once we add the note in, we'll also play an audio cue to indicate the fact that the note was dropped. So we'll actually play the appropriate drum sound for that track. So looking to global state, we'll grab our sound engine, and we'll play the index given by edit track. And finally, since we have, at this point, affected the song in some way, we'll mark the fact that we have changed something by setting changed to true. And that should cause us to invoke the save prompt once we're done with the edit mode screen. Alright, that takes care of adding a new note. Now let's address removing a note. So basically, if note was not null, that meant note pointed at a real actual note, we need to remove that note. So we can look at song.notes, we can call remove, and we can pass in a specific note item. So we'll simply pass in the note variable. So we'll tell it to remove that note. And again, having removed a note from a song, we have changed the song. So make sure we indicate that by setting changed to true.
Now, would it be better to take your changed equals true line and just move that outside the if statement? Or does it really matter?
In this case, I guess you could, because as soon as you're dropping a note down...
Yeah, just a kind of a personal style thing.
You could. I'm trying to think of if there was ever a scenario you would hit a note, and a note get neither added nor removed.
Yeah.
If that was the case, you would want to do it individually.
I gotcha.
Looking at the way the code is slated here, you could probably do exactly what you're saying and put changed outside of it, and that way you'd only have to adjust changed once. But again, that's all a matter of preference and where you place that. But with this last bit of code added, we should be ready to test. We've got note adding and note removing. So let's jump into the game, go into our song editor, load up a song, move the cursor somewhere, and then hit a note button. In this case, we were in our code not specific as to what note, so really you could hit any drum button, and that would read as a note value. So on the keyboard, we'll hit the Z key. You can see that has dropped a note in place.
You can hear it too.
And there was an audible note being played to indicate that it was added. So we could drop to the track below, add a snare, a tom, and so forth.
You have to be a really talented drum player to do that.
Because at this point, yeah, that's 4 simultaneous hits. So.
Yeah, you need 4 arms, basically.
So let's also test toggling. So now that we've added these notes, let's move the cursor so that we select this tom note, and if we hit our note button, it removes it. We can remove the snare, and we could remove the hi-hat. So if we leave the cursor in one place, you see that we just toggled the note over and over. So with that now, let's test one other thing, and that is our changed value. At this point, if we hit escape to jump away from the edit screen, we're presented with a save prompt. So it has noted the fact that the song changed, recorded the fact that it's a 2x bass song that has changed, and it's asking us if we want to save. Since this is a pre-generated song, we don't want to mess up the song at this point, so we'll select no, and that should discard all the changes. We could test that by loading the song back up, and you can see that all of our changes are in fact gone. Also, if we don't make any changes, we're free to skip back out of the edit mode, and it doesn't bother asking us.
Which is good, because we haven't changed anything, so there's nothing to save, really.
Now, to test saving some notes, let's load up one of our free play recorded songs. We'll load up free play 1. And let's jump in here and add some additional hi-hat notes. Now you can see we have 4 notes added to the beginning of the song. If we hit escape, we'll hit yes to whether we want to save free play 1. And then if we load free play 1 up again, there we have all of our saved notes.
Nice.
So again, we could add something more visual, add some snare notes, save, yes, load that up, hit something like we didn't mean to hit, maybe an extra kick or a crash note, save, no, load back up. We have full saving and loading. So with that now, we now have note edit mode fully functional. We have the ability to manipulate the cursor. We can move the edit cursor around the screen freely using the direction keys. We can toggle notes, and we have set up the necessary rendering code to draw the edit cursor itself.
So it seems like at this point we need to start thinking about some of the functionality of those other modes.
Exactly. We have these modes here for seek, tempo, and so on. So now we'll need to begin addressing these modes. But we'll do those here in the upcoming videos, so that will take care of this video.